My yogurt maker broke down. Well, not this way, but it didn't work anymore. So let's see if we can open it. It has these funny screws, but with the right tool it's possible to open it. At least it's not glued together or somehow difficult to open it. So let's screw it open and see what's inside. Okay, you see that's a lot of work, but yeah, we are curious. And that's how it looks inside. Yeah, not much stuff in there. Remove the outside cover as well. Okay, we have some cables dangling around. And these small things seems to be the heat elements. Okay, yeah, they don't need to be bigger. They just have to warm it a little bit and keep it warm. So let's see what we have here. So this is only the yogurt tray with the heating on it. Put it away, and we have some electronics. So we directly see this big capacitor which doesn't seem to fit really on the board. It has only 1 microfarad, but the voltage is enough for mains current. This seems to be the temperature sensor. It was located near the tray, but we'll test this later. So this is how the electronic looks like. So we see the display here and the connected temperature sensor. So when we look at the backside, we don't see anything suspicious here. Everything seems to be in a good shape. Let's inspect some of the parts. We have some capacitors here, some diodes, a Zener diode, and another Zener diode, a controller chip, a transistor which controls the heating. Let's check the temperature sensor. The resistance goes down when I heat it up with my fingers. And it goes up again when it cools down. Maybe there's a failure in the power supply, so I connect my lab bench and put some power from my lab bench in. Okay, yeah, looks fine, it works. So the power supply must be broken. Let's check this out. Doesn't seem to be very obvious how the power supply works. So I searched on the internet and I found this circuit here. This seems to be the circuit on the board. So we have the resistor, we have the capacitor, and we have the Zener diode here. The capacity of the capacitor determines the power which is provided by the supply. Some capacitors deteriorate over the time, so the capacitance of the capacitor may be not as it was before. Let's plug the board in and see if we still have the same symptoms. Yeah, looks like. It's still broken. This is the capacitor we are talking about. I found one replacement in an old microwave. It has a similar capacity, but it seems to be more sturdy for the microwave. So, but let's connect it and see if this would fix our issue. So just put it in parallel with the old one, start it, and it works. I found a smaller capacitor just to get this capacitor over the threshold. Let's see if this works. So I put it in parallel so the capacitance can add up. And I soldered it in. Let's see what happens. Yeah, it works. So this would be the fix for my issue. But just to be sure, I'll measure the capacitance of my capacitor doubles here. So what do we have? 0.3 microfarads. That's far away from the 1 microfarad we need. This is rather disappointing, especially since my capacitor seems to be broken too. How does the replacement behave? 950, that's good. So now it's time to put everything back together. So we stick the temperature sensor here, so it has to be very near to the tray. And then the electronic comes in. We see the big capacitor, the blue one, which takes up some space, but we have enough space in the case. So put the lid on. Okay, doesn't fit so well. And now I'm more clever and use the cordless screwdriver. Ah, this goes really fast. Okay, just fix the cable and then looks like we're done. So this was a fun little project. I wasn't sure if I can fix it, but it was a success. So I hope you liked this video. See you in the next video.